Newton's first law is what is applied to this situation. It can also be applied to a rocket's liftoff. According to Newton, every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Before the rocket fires, the object is in the state of rest and the airspeed is zero. When the engine is fired, the thrust increases from zero to some sort of other higher speed, and the weight decreases slightly as the fuel burns. When the thrust is greater than the weight, the net force will force the rocket to go up. Rockets accelerate upward, and that increases their velocity. The next three clips are of my experiment demonstrating Newton's first law. My experiment showed that when the Jayhawk was traveling at the constant velocity on the treadmill and was suddenly stopped, that the Jayhawk still continued in the straight line pattern at which the velocity would have taken it. Newton's second law is that force, acceleration, momentum, and velocity are all vector quantities. Each has both magnitude and a direction. It is known that force equals the change of momentum with change of time, which is demonstrated in the mathematical equation F equals d times mv over dt. When mass is a constant, the equation is the force equals mass times acceleration, which is the common physics formula F equals ma. Now, another equation that is often used when mass is a constant is force equals mass times the change in velocity with the change over time. So that's F equals m over the change in velocity divided by the change in time. Newton's third law is for every action there is an equal and opposite reaction, as demonstrated in the picture of the rocket engine thrust. When the engine is pushed forward by the thrust, the exhaust flow is pushed backwards, therefore proving Newton's third law to be true.